This video is about distance time graphs, but just sketching them. So we're getting away from the kind of the numbers, and just by the end of this video, you should be able to look at the shape of a graph. It goes up, it goes down, and go, oh yeah, I see what's happening there. Okay, so these are your moves in a distance speed time graph. If you go straight across, there's no change in whatever's on the y-axis. In this case, it's distance, so no change in distance is stopped. Then you've got slower forward as you get more vertical, super fast forward as you get faster and faster. So if we were to, I don't know, put in like a protractor, this would almost be like how fast you're going here. So you could say that like this would be stopped. You think of this almost like a speedometer, getting faster, 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 super fast. You can never go past here. That's like infinite speed up here. So, and then it's going to be backwards if you were to go down the other way. Slower, slower. Well, you're going backwards. The second you cross here, you're going backwards. And then you're going faster, backwards, faster, 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 faster. And again, you can't really go past the absolute vertical. But as you approach vertical, that's as fast as you can pretty much go. All right. So let's do an example. So if this Skeletor little guy here goes along a track, now in a distance speed time or a distance time graph, you can only do very simple motions. So no going up, left, right, backwards, and in circles. It's just the rules are you can go forward along a track or up in a height along one axis. You can go fast, you can go slow, but you can only go in one direction, either forwards or backwards. So if you look at this guy here, if we were to say he stopped there for a while, didn't move, so let's say he stopped there for 2 seconds, we could just draw a little arrow here to say he stopped for about 2 seconds. And then if he very slowly started to kind of creep forward like this, we could say, now he's slowly going forward. So we just add a going forward arrow and a slow one. And if he stops there again, we could say, oh, he stopped there again for another bit. And let's say he just decides to go, ha-ha, and fly up here real fast. Like, okay, he went pretty fast there, so we'll add a more vertical arrow. And if he stops there, that's stopped. So this would be the motion of him on a graph. And in an actual graph, you wouldn't have to draw the little jaggedy arrows. Probably a bit smoother, so something like this. There you go. That'd be the shape of your graph. All right. So once he's already there, don't forget he can go backwards as well. So let's say he starts. Now he's about 8 meters away. So he's starting at the 8 meter mark, and he's gonna go very slowly backwards down this way. So what are we going to add? Well, a slow backward one. And let's say then again he stops there for a little bit to take a break. And then of course he runs all the way down to about here. Let's say he goes fast, fast, all the way, and then he'll stop around there. There you go. Okay, so and if he was to bounce off and fly back up, we'd say fast forward again down here. Right. So to get away from cartoons, you can do this looking at a plane or something like that. So this is the F-35. This thing takes off vertically. So we're just going to look at the vertical height on the graph. So it's on the runway. It's really stopped at the moment. So we'll add a stop arrow to say it ain't going nowhere. Oh, it's moving, it's moving. I better put a slow forward one. There we go. So it's moving up very slowly. And now once it goes from its hover engines to its wings, it's going to climb very fast. It's going to fly up into the sky. So I should add a big fast arrow up here. Now I'm going to say stopped. Wait, hang on a second. That plane is flying forward. Why did I just add a big stop arrow saying stop? Well, don't get this confused with lefty righty. This is an uppy downy graph. This is just height. So if it's just height, he's gone up to a certain height and now he's flying around really fast at that height. But I should say stop here because he's stopped at a certain height. and he'll stay at that height for a little while. Do a few flips and that kind of stuff, play around, and now he's going to start coming back down pretty fast until he sticks his wheels out, and he's going to slow it down a bit using his hover jets are back on again. Well, he doesn't actually have hover jets, it's more so he's directing the jet downwards. Slows him down, lovely. Here we are, he's on the ground. He stopped again. Happy days. Cool beans. Okay. And you can do this as well with something that would look like this. Very fast forward, flying up. A shuttle launch, or Robin flying. Launch, yeah. So it flies up in the air, and see if you can predict in your head what this graph is going to look like. I'm going to stop. I should keep adding these, but I'm not going to have enough room, so I'm just going to pretend it's going up and up and up and up and up. Oh, not anymore. It's having trouble. Alright. I think it's stopped there. And it's heading down pretty fast. Definite stop. Okay, so just know that this is going in one direction, and then this is going in another, right down. Alright, so what kind of super fast object could make a graph like this? What's going on in the graph basically? So have a look at that for a sec. So the red line must mean it's stopped as it's going along the red line there, and then it shoots off into the sky. And if you were to look at the numbers, we're just sketching here, but you could see it's gone time from 3 to 4, which means 1 second, 3 seconds to 4 seconds, and it's jumped from 0 to 8. It's pretty fast. It's gone 8 meters in 1 second. I don't know, maybe like a rocket, something pretty crazy. What about what? Now, this shouldn't make sense. It doesn't make sense. You will never get a graph like this. Normally, you know, things can go forwards and backwards, but this is not going backwards on distance scale. This has gone from 3 seconds in time back to 1 second, which means it's gone back in time. Yeah. So you'll never get an arrow like this that will pass the vertical. It will only ever go from flat to there, to there, to there, to there, or maybe up to here. That would be almost the speed of light. It never even goes up here. The second you cross to go faster than the speed of light, you start going back in time. So that's crazy. You're not going to get that. And then, as I said, it's not always a super jaggedy line situation. If you were to break up this curvy line into little arrows, you'll see that what's going on here. This arrow is a lot faster than this arrow. This arrow is almost stopped. It's almost at that kind of flat line, not moving stage. So you can see that it's gone from very fast to kind of fast to not so fast to completely stop there. So this is a gradual slowdown, and this then, the coloured rainbow line would be a gradual acceleration. And that is about it. That's sketching a graph.